Well, exciting news today here at 5:22 this morning. The new James Webb Telescope reaching deeper into the universe than ever.
The James Webb Space Telescope, JWST, launched in December 2021, has become one of humanity's most powerful eyes in space. Designed primarily to peer deep into the early universe and study the formation of galaxies, stars, and planetary systems, it has also proven itself invaluable for detecting nearby cosmic phenomena. Recently, it made a discovery that has stunned astronomers and rippled through the scientific community. A massive object previously undetected is approaching our solar system. This revelation, still under intense study, has drawn global attention not only because of the object's sheer size, but also due to the implications of its trajectory and nature. Before we start, hit the like and subscribe buttons for more exclusive news. The object was first identified through a sequence of infrared signatures captured over several observation periods. Initially, it was mistaken for a cold, rogue planet, perhaps a gas giant drifting through the darkness between stars. However, as data piled up, inconsistencies began to emerge. Its thermal output was too irregular. Its mass, inferred from gravitational interactions with background stars, suggested something more substantial, yet the object emitted almost no visible light. It was not merely another celestial drifter. This was something unprecedented, immense, dark, and moving, with a vector that places it on an intercept path with the outer boundary of our solar system. Further observation refined its parameters. The object is roughly the size of Neptune, yet its density is far greater, suggesting it may be composed of exotic matter, or encased in a shell of dark material. Its current position lies just beyond the heliopause, the boundary where the solar wind's influence fades and interstellar space begins. What makes this event remarkable is the rate of its approach. Unlike the slow, drifting motion of comets or asteroids kicked into long elliptical orbits, this object exhibits a deliberate acceleration pattern. It's not moving with the inertia typical of natural interstellar wanderers. There is a growing unease among observers that something else may be at play. The JWST's deep field imaging capabilities enabled astronomers to trace the object's origins with moderate precision. Data suggests it originated from the direction of the Scorpius-Centaurus Association, a region teeming with massive stars and frequent supernovae. Given that environment, the object could be a remnant of a stellar collapse, possibly even a primordial structure formed in the early galactic halo. If true, this object predates Earth itself. Its composition, trajectory, and behavior all hint at an origin that defies existing astrophysical models. The implication: our understanding of interstellar dynamics may be incomplete, and this object is a manifestation of forces we've only theorized. Gravitational lensing effects observed by JWST and supported by terrestrial observatories revealed that the object's mass warps light more significantly than anticipated. That discovery led to speculation that it may possess a dense core, perhaps a chunk of degenerate matter akin to what is found in neutron stars. Alternatively, some theorize it could be a rogue black dwarf, a stellar corpse that has cooled over billions of years, now hurtling through space after gravitational ejection from its birthplace. But its heat signature complicates this theory. It emits just enough radiation in the infrared spectrum to contradict the black dwarf hypothesis. The internal source of that heat is a mystery in itself, possibly driven by quantum phenomena or interactions with ambient interstellar fields. One of the most alarming features of this object is its influence on the Oort cloud, the vast spherical shell of icy bodies that surrounds the solar system. Already, subtle perturbations have been detected among the outermost objects. Comets and dwarf bodies have shifted in ways that suggest the massive visitor is exerting a gravitational pull. This pull isn't just a passive consequence of the object's approach. It appears to have an asymmetrical effect, disproportionately affecting objects in a specific vector. Some astrophysicists believe this points to a rotating gravitational field, possibly indicating that the object is spinning rapidly or surrounded by a dense, magnetically charged halo. Such an entity entering the periphery of our solar system raises profound questions. Could it bring with it a swarm of companion objects, unseen and following in its wake? Could this be part of a larger structure, a fragment of something even more massive? These are the questions that dominate scientific forums and emergency gatherings of global space agencies. Missions that were once theoretical or planned for the distant future are now being fast-tracked. The object's entry into the solar system's domain is not only a challenge to our understanding of astrophysics, but also a potential milestone in humanity's relationship with space. While the JWST continues to monitor the object, other observatories have joined the effort. The European Space Agency's Gaia mission has contributed crucial data on background star shifts, providing more clarity on the object's gravitational influence. Meanwhile, the Vera Rubin Observatory, though not yet fully operational, has expedited commissioning to assist in wide-field tracking. Even older platforms like Hubble and the Chandra X-ray Observatory have been repurposed temporarily to aid in spectral analysis and search for high-energy emissions. Across the globe, the scientific infrastructure is mobilizing like never before. As tracking continues, a curious pattern has emerged. The object's trajectory is not perfectly linear. Small deviations in its path suggest it is responding to gravitational features in a manner more consistent with active course correction than passive drift. This has led to one of the most controversial and hotly debated questions in modern astronomy. Is this object entirely natural? The idea that it could be an artificial construct is not being dismissed outright. Though still a minority viewpoint, it is gaining attention due to the peculiar regularities in motion, heat dispersion, and the object's overall morphology as viewed in infrared mapping. A toroidal structure was briefly visible during one of JWST's long-duration exposures, though later dismissed as an imaging artifact. Still, the possibility lingers. The size of the object, if verified, would make it one of the most massive bodies to enter the solar system in recorded history. Larger than any known comet or asteroid and denser than most planetary bodies, it is in a category of its own. The gravitational implications are enormous. Should it penetrate far enough inward, its interactions with the gas giants, especially Neptune and Uranus, could shift orbital parameters, subtly or significantly depending on its mass and proximity. Even if it remains in the outer solar system, it will likely redefine the boundary of the Sun's gravitational influence and could reshape models of long-period comet origins for generations to come. Adding another layer to the mystery is the object's lack of a visible tail or coma, features typically associated with icy bodies entering the inner solar system. This further rules out typical cometary classification. Its surface, as mapped in the far infrared, appears non-reflective, possibly composed of carbon-rich compounds or a material yet to be categorized. This darkness makes optical detection nearly impossible. JWST's success in finding it was a fortunate consequence of its unparalleled sensitivity in the infrared range. Radio telescopes have been directed at the object in hopes of detecting any emissions or irregularities. So far, results have been inconclusive. There are periodic pulses, faint, regular, and distinct from background noise, that some interpret as rotational signals or natural emissions from internal processes. Others are more skeptical, demanding further confirmation before assigning significance. Nevertheless, SETI, Search for Extraterrestrial Intelligence, has initiated passive listening campaigns, not out of panic or speculation, but out of scientific prudence. The nature of the object, combined with the lack of precedent, warrants the most comprehensive analysis possible. Not since the discovery of Oumuamua in 2017 has a cosmic visitor stirred so much intrigue, and this new object dwarfs Oumuamua in both size and enigma. The prospect that it may interact directly with the solar system's architecture gives it far more importance. Unlike prior passers-by that simply grazed the outskirts of the solar domain and departed, this one is inbound with a purpose, or at least a momentum, that implies long-term engagement. This encounter challenges more than just our observational capacity. It stretches the limits of planetary defense theory, deep space navigation, and even our philosophical views on isolation in the cosmos. The JWST was never intended to track threats or monitor incoming celestial bodies, yet it has now become the sentinel of Earth's sky, revealing an event that could shape the destiny of this solar system. Instruments designed to study distant galaxies and primordial starlight have instead opened a portal to immediate and tangible concern. If you like this video, please give it a like and subscribe to our channel. Also, could you leave your comments below and tell us? What are your thoughts on the massive object approaching? Will it affect Earth soon? We want to hear from you. Thank you for watching and see you next time.